And welcome to SanfordFlipMath, the home edition, Algebra 1. We are solving quadratics. We've been working on quadratics, multiplying and factoring for quite some time. We've done a little bit of solving by factoring from the zero product property, but now the question is, what happens if you can't factor? Well, that's a bit of a problem. Some things won't factor, but that does not mean there are not solutions to the quadratic equation that you're working with. So we are going to work with something called the quadratic formula. You may have seen it before. It's big, it's ugly, it's scary. And yes, you need to know it. You need to actually memorize this thing. I will post a link for Emily, who's a 4-year-old that knows the formula. She probably has no idea what she's talking about, but it's actually helpful for memorizing it. You want to memorize it. To pop quiz the weasel works. There are other ways. There are many videos on how to remember the quadratic formula. So all that to say, we're going to work with the quadratic formula. At some point, we will talk about and you will learn about where it comes from, but that is not going to happen right now. Time is of the essence, so we're going to be a little expedient about it. You need to write this down. It needs to be very carefully written, and I'm going to point out some things that are places where people mess up. So it is x equals, people say negative b. It's technically the opposite of b, but I mostly say negative b also. Plus or minus. Remember, with most quadratics, you get two solutions. The one comes from the plus, one comes from the minus. Big square root, b squared minus 4ac. So that square root has to cover the entire part of that. This part on the inside is called the discriminant. We don't really need to know that right now, but that's true. Fraction bar goes all the way, not just under the square rooty part, but under the negative b also, and then 2a on the bottom. So again, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Fraction bar goes all the way across. The square root covers all of this b squared minus 4ac, and there is a whole boatload of, please excuse my dear Aunt Sally, order of operation stuff that's about to happen. All of this is assuming that we have a quadratic that's equal to 0. And again, it's using that same format that we've been using now for weeks. Ax squared plus bx plus c equals 0. So it needs to be in order from the squared to the not squared to the no x at all, and then equals 0. Okay. All right. So that is the quadratic formula. It didn't tell you anything about where it comes from right now because time is an issue for us. All right. So we're going to solve this quadratic using the quadratic formula. All right. So as I look at this, remember a is the number in front. Well, it's actually 1 in this case because there's no number out front, and 1 times x squared is just x squared. B is negative 5. C is 4, so we're going to write those down, and then we're going to follow the formula. Okay, so again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the formula that we're going to use. So here we go. Negative b, so I'm going to do negative of negative 5. And I know some of you are going to start combining some steps already, and I understand that. Now, here's a common error right here. It's b squared here, so I'm going to write negative 5 squared. But technically, the way this is written, that's not negative 5 being squared. That's really only the 5 being squared, and then we make it negative. And if you type it into a good calculator, it's going to give you the wrong answer unless you have parentheses there. Minus 4 times a times c. So I'm just filling in the numbers, all over 2a. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I know I'm talking fast. All right, so the negative of negative 5, the opposite of negative 5 is just 5. Negative 5 times negative 5 is 25 minus 4 times 1 is 4, times 4 is 16. All over 2 times 1 is 2. So I'm being a little careful about my order of operations here. Now, you are welcome to type some of this into your calculator. Just be careful that you're typing things in correctly. Like you can type in negative 5 in parentheses squared minus 4 times 1 times 4, and it'll be 9, and it'll work. That's all good, provided you type in the parentheses here, and 4 times 1 times 4, that works. So this is now 9 over 2. Sorry, I'm running out of room here. Okay, so equals, now what's the square root of 9? Okay, Now, what we're actually going to do is split this up into two separate little calculations. 5 plus 3 over 2, or 5 minus 3 over 2. So this is 8 over 2. This is 2 over 2. And we get two solutions. Now, if your solutions come out nice and clean like that, that really means we could have factored this. So just a little split off here. This would have factored into x minus 1, x minus 4 equals 0. So x minus 1 equals 0, x minus 4 equals 0. So this would have been probably easier to solve by factoring, but I wanted to show you rather one that's quadratic formula with easy numbers, with numbers that look pretty. So if it comes out with easy numbers, that means we probably didn't need the quadratic formula, but that doesn't mean I wouldn't ask you to do quadratic formula anyway. Okay, so typically with quadratics, as we said before, you get two solutions, whatever that degree is, whatever that highest exponent is of the equation, that's usually how many solutions it has. It is possible to have the same solution repeated, like if this would have been 5 plus or minus 0, 5 plus 0 and 5 minus 0 would have been the same thing. So it is possible to have the same solution for both of them. That's the thing. All right, so that's one. We're going to do two more examples, and these will be less cute. They're going to be kind of ugly. So I'm just going to warn you right up front. Okay, again, this is ax squared plus bx plus c equals 0. That is standard form for a quadratic. It must be in standard form to use the quadratic formula. So I'm just writing down the formula again because I know we need to see it a lot now. So negative b plus or minus square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Just saying, that's a spoiler. All right, so here we go. The a is 3, the b is 3, the c is negative 5. So I'm just peeling these numbers off of here. It's already in standard form. So x equals negative b, so negative 3 plus or minus the square root of b squared minus 4ac all over 2a. Super easy to make sign errors in here, so please, please, please be careful. Negative 3 plus or minus the square root of, well, 3 squared is 9. 4 times 3 is 12. 12 times 5 is 60. This is technically a negative times a negative. It's really plus 60. So I need you to think about that. This is one of those spots that is super easy to make mistakes. So again, this is called the discriminant. It helps us decide what kind of solutions we're going to have. But that's the spot you really need to be super, super careful, along with fraction bar that goes the whole way, or square root that goes the whole way. All right, over 6. Okay, so x equals negative 3 plus or minus the square root of 69 over 6. Now, here's the question. Can we simplify this more without making an ugly mess? Well, 69 is 3 times 23. 23 is prime. What I'm looking for are there any perfect squares in here that I could maybe factor out and take that perfect square? Like, for instance, the square root of 12 is 4 times 3, and the square root of 4 is 2. You can actually simplify this square root to 2 root 3. Well, this square root doesn't simplify. So all that to say is, if you are not looking to round, this is actually done. This is actually done. I know it doesn't look like it's done, and that's kind of an awkward spot to be in, but it's still true. That is done. Now, if the problem asks you to round it, find it the decimal to the nearest something, nearest 100th, 1000th, 10th, whatever, then we can do some typing. So I'm going to type in negative 3 plus the square root of 69. Now this is just the top, but I want the top to be done as one big chunk. Now I could have put parentheses around it, but I'm just going to do it separately, and then I'm going to divide by 6. So this is 0.884. I usually like 3 decimal places, 1, 2, 3 after the decimal. Now I'm going to redo this because there's no way to type in a plus or minus on the calculator. What I need to do is retype in the top. So I'm going to type in -3 minus, because that's the or negative, plus or minus, whatever. Okay, again, I'm going to hit enter, and then I'm going to divide by 6. So -1.884. Okay, so those are the two solutions if we round it. So this is technically two solutions, -3 plus square root of 69 over 6 and -3 minus square root of 69 over 6. This is those two solutions worked out as decimals. Okay, so it depends on what the question's asking. If it wants simplest form or simplest radical form, or if it just says simplify, that's this. If this said round to the nearest thousandth, that's what this is, right? It just depends on how the question's asked, okay? All right, one more example, and then we'll be done, okay? This problem is not in standard form. I do see an x squared. I don't know if you see it yet, but I do see an x times x there. Now remember, I want this to look like ax squared plus bx plus c equals 0. This does not. So I need to multiply some stuff out, and I need that equals 0, so that means everything needs to be on the left side. So here we go. X times x is x squared plus 3x equals 5x plus 10. So all I did was distribute. I'm trying to get it to look like this. Now, again, this has equals 0, so anything on the right side needs to be moved over to the left side. So in other words, I'm going to subtract 5x from both sides. So x squared minus 2x equals 10. I'm going to subtract 10 from both sides, because again, I want equals 0. Well, I got my equals 0. Now, worth noting, this 10 is not a like term with anything, so I'm just going to rewrite this. Okay, so now this is standard form. This is me just getting it ready so I can actually do the math, right? I couldn't even do the quadratic formula yet. So this is ax squared plus bx plus c equals 0. So the a is the number in front of the x squared. The b is the number in front of the x. And the c is the number at the end that doesn't have an x at all, and you need to bring the sign along. If it's minus, make it minus. If it's plus, then you can just write the number without anything. All right, so here we go. X equals -b. Now again, if you want to do the negative of -2 right now, you can, and just skip to the whole next thing. But I'm going to err on the side of safety. People make mistakes here all the time. Okay, especially on the inside of this thing. It's always 4ac, so this 4 is just part of it, okay? And then times a, okay, times 1, I guess you don't really need to write that, times c, times -10. I need you to be super, super careful on the inside with, again, the discriminant, okay? Okay, so I'm going to pick up here. Negative of -2 is 2. This is -2 times -2 is 4. I don't care what your calculator says. If you don't put parentheses on it, then it's not squaring the negative, okay? Minus 4 times 1 is 4, times 10 is 40, minus a negative, that's really going to be plus 40, and 2 times 1 is 2. So I'm going to add those. Okay, we're getting close now. Now, 44 is actually 4 times 11. I can do the square root of 4. So this is simplest radical form. Well, we're on our way to simplest radical form, because the square root of 4 is 2. The thing you do the square root of comes out, because we already did that square root. Okay, so x equals. Now, it turns out that every one of these terms can be divided by 2. So 2 divided by 2 is 1. Okay, you can't just cancel them out and think, poof, they're gone. It's literally 2 divided by 2 is 1. And 2 divided by 2 is, again, 1, leaving just the square root of 11. This is simplest radical form. This is as simplified as possible with this problem without doing a decimal approximation, okay? So this is done if it just said simplify, or simplest radical form. If they want it rounded, then we're going to do some typing, okay? So here we go. Okay, so 1 plus the square root of 11. So 4.316. but the next digit is 5 or more, so I'm going to make that a 7. Okay, now I'm going to show you something sneaky. If you are on a fairly modern TI-84 or TI-80, whatever, I can push up arrow and until I highlight that, and I can actually hit enter and copy it. And what that lets me do is go in and edit it. Now, is that easier than typing 1 minus the square root of 11? Probably not, but it's cool anyway. All right, so there it is. It is going to be assumed as you go into geometry and algebra 2 that you know the quadratic formula. Again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, that was the end of number 3. Okay, all right, but there's the formula. I'm going to leave it on the formula. I need you to practice it. So again, what a lot of people do is pop goes the weasel for this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I've had classes singing that for years. It helps. So anyway, for quadratic formula, I didn't tell you the background of it, and that is kind of a big deal. But again, time is the issue right now. So if you know what's going on in the world right now, you know what's going on. All right. So much love to my people. I will see you in the room or on the Zoom, as it were. And Sanford Flip Math, we're out. Bye.